With one of my favorite 3D shapes because it holds ice cream. Who wouldn't love that? Anyway, we're going to do a new shape, which is the cone, and we're going to talk about how much stuff fits in a cone. So we're going to be calculating volume. Now, normally, if we were in class, I'd be doing this demonstration of showing you how a cone and a cylinder relate. And I'd be using my plastic shapes, and I'd actually be using some rice. Can't do that here, so I did find one online. So let's take a look at this comparison of the volume of a cone to a volume of a cylinder. Just give me 1 second, and I'll get out there so we can watch it.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is 1/3 of the volume of the cylinder.
She did a lot better job than I do with the rice, in that I don't think the woman spilled a single drop. I usually have rice all over the floor. But what you should have just noticed is that the cone will fill up the cylinder 3 times. So the cylinder has 3 times the volume of the cone. And if we reverse that thinking, the cone has 1/3 of the volume of the cylinder. So if we know the formula for a volume of a cylinder, which we just talked about, the only thing we have to do to get a cone is to divide it by 3. That's the same thing as multiplying it by 1/3. You're going to see me using the dividing by 3 idea because it works better in your calculator. So again, just to show you a picture here, here is the cylinder. Remember, we take the volume equals the base area, the area of the circle, pi r squared, times the height. The cone is going to be the area of the base, the area of the circle, pi r squared, times the height, but we're going to take 1/3 of it. We're going to divide by 3. This idea we already kind of talked about when we compared the pyramid to the cube and realized that the square pyramid has 1/3 the volume of the cube. So it's the same idea that where that shape comes into a peak, so in the pyramid it comes to that top vertex point, all this other volume is missing. It's taken away. So 1/3 of the volume is inside the pyramid or the cone, and 2/3 of the volume would be outside of it. So today, let's take a look at what we just discovered. And you're going to notice now, I know that you guys don't have your books, so notes pages and any homework assignments out of the book, I will be scanning the pages and attaching them to Classroom. So I know you don't have your book, but a cone is a 3-dimensional figure that has one circular base, unlike the cylinder that had 2. It has one circular base, and it's connected to a single vertex at the top. It has that sharp point. Now you're going to notice they're talking about the volume being 1/3 the base area times the height. Remember that the base area, the capital B, is a circle, so the area of a circle is pi r squared. So this is the formula the book's using. I am just going to change that slightly. Instead of multiplying by 1/3, that's the same operation as dividing by 3, and this is the easier way to do it in the calculator. And that's kind of what I'm showing you down here. Here are the buttons on the calculator that you would use. So you would put in your radius. What is the distance from a point on the edge of the cone to the center of the base? That's the radius. And you would square it. You'd hit the x squared button. You'd multiply it by the height. How tall is the cone running from the vertex to the center of the base? That would be the height. And then we're going to divide it by 3, and then you hit enter. Now, if you were to stop right there, that number would be your exact answer with a pi written after it. Once you hit times pi, you're going to be approximating the volume of the cone. So let's take a look at an example. So here's an example of a cone. It has a radius of 3. Notice it only goes from the center to a point on the edge of the cone. It's not the diameter, it's the radius. And then the height is 6. So we're going to take, just like we did for the cylinder, we're going to take the radius squared times the height times pi, but we're going to divide it by 3 because it's a cone. 3 squared is 9. 9 times 6 is 54. 54 divided by 3 is 18. I haven't multiplied by pi yet. This is considered my exact answer. The minute I take my calculator and take 18 times pi, I'm giving an approximate volume and estimate, and it's about 56.5 inches cubed. And we will be rounding to a tenth. That means you leave one decimal place on your answer, and you only look one place past that number when you're rounding. Here are the steps. You would have taken 3, hit the squared button, times 6, divide it by 3, and hit enter, and 18 would show up on the calculator. Once you hit times pi, you should see the 56 point, and again, we're rounding to 5. Our units for volume, again, are cubic, 3 dimensions, inches cubed. Make sure you always put your units, and for volume, make sure they have a 3 as an exponent. Let's take a look at another example. A cone-shaped paper, so cup. So you see I'm kind of making sure I know it's a cone and not a cylinder, so I'm underlining that as I read through my problem. It's filled with water. The height is 10 centimeters. So from that sharp point down to the center of the base is 10 centimeters. And this time the diameter, now the diameter is going to be the entire distance across the base running through the center, and that's 8 centimeters. We don't use the diameter in our formula to find the volume for a cone, so I'm going to cut that in half. Half the diameter is the radius, and that's where this 4 is coming from. Radius squared times height divided by 3. So 16 times 10 is 160. Divided by 3 is 53.3 repeating, and I'm going to put the bar there and stop, put the pi on. That's my exact answer. Need the bar on there to know that it is your exact answer. And I'm going to leave that 53.33333 in the calculator, multiply it by pi, and now that's approximately equal to 167.6 centimeters cubed. Here are the steps in the calculator again if you need them. I'm going to move on. We're going to just do 2 more examples, and then I think you'll be ready to give it a go on your own. So what I'd like you to do is to pause the video right now and try to find the volume of both of these cones. And in a second, we will come back and see how you did. Okay, everybody, let's take a look. They gave us the radius here, the diameter there. So this one's going to be the easier one because we have what we need. So the radius is 2 feet. The height is 7. So here is my formula. Again, I wanted to just mention that you will see the formula in most textbooks is 1/3, but that is the same thing as dividing by 3. So 1/3 pi times the radius squared times the height. Now I'm going to get out here and I'm going to take the 2 squared, which is 4. I'm going to multiply it by the 7, and I'm going to divide it by 3. And you should see 9.333333 in the calculator. I'm going to put my bar notation with my pi, and that's called my exact answer. I have not approximated, and I haven't multiplied by pi yet. Now, the minute I take that 9.33333 and multiply it by pi, then I will have my approximate volume. It's about 29.3. Don't forget your units of feet, and since it's volume, it should be a 3. Area is square area, and straight units, like measuring your height, would be an exponent of 1. But when you're finding volume, you need to have a 3 up there. Okay, let's take a look over here. Notice that the first thing I did was take that 24 and divide it by 2. I cut it in half because I've got the long guy and I need the short guy. So you take the diameter divided by 2, there's your radius. Again, here is the formula as written in the book. 1/3 pi times the radius squared times the height. I'm going to take that 12 and square it, multiply it by 26, and divide by 3. And I will see in the calculator 1,248. And if I write a pi after that, that's my exact answer. Take the 1,248 times pi, and it's approximately 3,920.7 millimeters cubed. So again, there is our volume formula that you'll mostly see out in the real world. That's how it's written. But please remember that that is the same thing as dividing by 3, and this is the easier way to do it in the calculator. Well, I hope that that helps get you started on finding the volume of a cone. It's directly related to our cylinder. It's the exact same formula as our cylinder, pi r squared h, but we just divide it by 3 to get the volume of a cone. Have a great day, everybody.